Look at a map of Europe. There, right in the middle of everything, between the coasts of Spain and Italy and Greece and North Africa, is the Mediterranean Sea. It's one of the most familiar bodies of water on Earth. Ancient civilizations grew up around it. Millions of people swim in it every summer. It has been there, blue and warm and permanent, through the entire span of recorded human history. It feels like one of the fixed features of the world. And it wasn't always there. Not just in the sense that things change over deep time. I mean something far stranger, far more specific, and far harder to believe. There was a period, several million years ago, when the Mediterranean Sea almost completely dried up. Not partially, not around the edges, the whole thing. This vast sea, which today holds an unfathomable volume of water, was reduced to a scorching, salt-crusted abyss, a colossal hole in the surface of the planet, kilometers deep, with a dead, blazing white desert of salt lying across its floor. Where cruise ships now sail, there was nothing but dry, sun-baked rock and brine. And underneath the Mediterranean today, buried beneath the mud of the sea floor, there is proof. A layer of salt. Not a thin crust. A layer of salt that in places is well over a kilometer thick, and in some spots may reach around 2 kilometers or more. Enough salt that if you spread it across the entire surface of the planet, it would cover the whole Earth. That salt is the corpse of an ocean. It is what a sea leaves behind when it dies of thirst. Over the next 40 minutes, we are going to descend into that lost world. We're going to walk down off the ancient shoreline, down the steep walls of a sea that isn't there, all the way to the floor of the dried-out Mediterranean, 3 kilometers below the level of the world's oceans, into one of the strangest, harshest, most alien landscapes this planet has ever produced. And then we're going to witness the moment the water came back, in a catastrophe so violent it may be the single most spectacular flood in the entire history of the Earth. If you want to make that descent with me, all the way to the bottom of a vanished sea, make sure you're subscribed before we go over the edge. Because we are about to stand in a place that should not be possible, on the dry floor of a sea that you have swum in. But before we go down there, we have to answer the obvious question. How on earth could anyone possibly know this? It sounds absurd. The Mediterranean is right there. It's full of water. There are no ruins of a salt desert visible, no obvious scar. So how did scientists ever come to the conclusion, which sounds frankly deranged the first time you hear it, that this entire sea once dried up and became a desert? The answer is that they went and looked, not at the surface, but underneath it. And what they pulled up from the bottom of the Mediterranean was so bizarre, so completely wrong for the place they found it, that it forced them into a conclusion nobody wanted to reach. This story starts, as so many of the best scientific stories do, with a drill, a ship, and a sample of rock that made no sense at all. Because there is a way of reading the history of the Earth that is a bit like reading the pages of a book, and it works like this. On the floor of any sea or ocean, material is constantly settling. Fine mud, the microscopic skeletons of tiny sea creatures, dust from the land, all of it drifting down through the water and gently accumulating on the bottom, year after year, century after century. That accumulation builds up in layers. The oldest layers are at the bottom, and each newer layer settles on top of the ones before. So the sediment on the seafloor is a stack of pages, and the deeper you drill, the further back in time you read. And crucially, what settles on the bottom depends on what conditions were like at the time. In a healthy, deep, open sea, you get one kind of sediment, fine muds full of the remains of the creatures that lived in the water above. But in a shallow, evaporating, hyper-salty environment, you get something completely different. You get minerals crystallizing out of the water as it evaporates. You get salt. So if you can drill down into the seafloor and pull up a long cylinder of the layers, a core, you can read off the history of that patch of ocean, in order, going backward in time. It's an extraordinarily powerful tool. And in the early 1970s, a scientific drilling ship took that tool out into the middle of the Mediterranean and started pulling up cores from deep beneath the seafloor. And what came up in those cores broke the story of the Mediterranean wide open. Picture the scene on that ship. The drill has bored down through the seafloor, hundreds of meters below the water, and the core samples are coming up, section by section, each one a slice of the buried past. The scientists on board split them open and start reading. And at first, everything is as expected. Seafloor mud, the remains of marine life, the ordinary expected sediment of a deep, open sea, page after page of a perfectly normal marine history. And then they hit something that stopped them cold. Salt. Not a trace of salt, not a slightly salty layer. Thick, massive deposits of evaporate minerals, the kind of thing that forms only when a body of water evaporates and its dissolved minerals crystallize out and settle. They found gypsum, a mineral that forms in evaporating hypersaline conditions. They found halite, which is quite literally rock salt, the same substance as the salt on your kitchen table. And they found it in enormous quantities, deep beneath the floor of a sea that is right now hundreds and hundreds of meters deep, and in places far deeper. That is not supposed to be there. You do not get thick beds of rock salt at the bottom of a deep open ocean. Salt precipitates out when water evaporates away, when a body of water is shrinking and concentrating, getting saltier and saltier until the salt can no longer stay dissolved, and it starts to fall out as crystals. That happens in shallow lagoons, in drying lakes, in places like the Dead Sea, in salt flats. It emphatically does not happen at the bottom of a deep, healthy, open sea, because a deep open sea is not evaporating away. So finding a massive layer of salt underneath the Mediterranean is like finding the fossilized bones of a camel at the bottom of a lake. It's not just surprising, it's a contradiction. The place and the evidence do not belong together. And here is what makes this discovery so extraordinary as a piece of scientific detective work. The scientists on that ship were not looking for a vanished sea. Nobody sets out to prove that the Mediterranean dried up, because it is not the sort of idea that occurs to a sane person. They were doing something far more routine, mapping the sediments of the seafloor, reading the ordinary history of an ordinary sea. And the evidence ambushed them. It came up out of the drill pipe and simply refused to fit any story they were prepared to tell. That is how the very best discoveries usually arrive, not as the triumphant confirmation of a bold theory, but as an inconvenient fact that will not go away, that sits there in the core tray refusing to make sense, until eventually someone is forced to say the unthinkable thing out loud. And it was genuinely unthinkable at first. When the idea was proposed that the entire Mediterranean had evaporated into a salt-floored desert, it was met with a great deal of resistance, and quite reasonably so. It is an enormous claim. Extraordinary claims demand extraordinary evidence, and a single strange core sample is not enough to overturn our picture of an entire sea. But the evidence kept coming, from more cores, from more locations, from the rocks on land, from the buried canyons, from the seismic surveys that revealed the true scale of the salt layer hidden beneath the seafloor. And piece by piece, the impossible idea became the only idea left standing. But it got stranger. Because as scientists studied these deposits and everything around them, they started finding other things that pointed the same impossible way. There were signs in some places of structures and textures that form in shallow water and even under open sky, of sediments that had been exposed to the air. There were the remains of the kinds of tiny organisms you find in extremely salty water, the specialists that can survive in brine that would kill almost anything else. And around the edges of the Mediterranean, in rocks now exposed on land in places like Sicily and Spain, geologists could see the same story written in the cliffs, thick sequences of gypsum and salt from the very same period of time, laid down in what should have been open sea. And then came the detail that, for me, is the most haunting piece of evidence in the whole affair: the rivers. Because if you take away the water from the Mediterranean, the rivers that flow into it, the Nile, the Rhone, and others, would suddenly find themselves emptying not into a sea, but into a colossal, empty hole. And a river that suddenly finds the ground dropping away in front of it does one thing. It cuts. It carves down, furiously, chasing that falling base level, digging a canyon into the landscape as it plunges toward the new, much lower floor. And that is exactly what geologists found. Deep beneath Egypt, buried under later sediment, there is a vast ancient canyon carved by the Nile, running far below today's sea level, gouged deep into the bedrock. Beneath the Rhone Valley in France, the same thing, a deep buried gorge. These are the fossilized scars of rivers plunging down into an empty basin, cutting canyons of enormous depth into the land as they raced toward a sea that had dropped away far below them. You cannot explain those canyons with a full Mediterranean. They only make sense if, at the time they were carved, the water was gone and the rivers were falling into an abyss. So now stack up the evidence. Thick beds of salt and gypsum, minerals that only form when water evaporates away, sitting under a deep sea. Signs of shallow and exposed conditions where there should have been open ocean. Traces of life adapted to extreme brine. And great river canyons, cut deep below modern sea level, pointing down toward a floor that was, at the time, far lower than any seafloor should be. Every single line of evidence points, relentlessly, to the same conclusion, and it is a conclusion that sounds mad. The Mediterranean Sea dried up, and there is one more line of evidence, hidden in the seismic surveys, that reveals the true scale of the thing. Because you can map a buried layer without drilling into it, by sending sound waves down into the seafloor and listening for the echoes as they bounce off the boundaries between different kinds of rock. Salt behaves very distinctively when you do that, and when geologists mapped the Mediterranean this way, the picture that emerged was breathtaking. That salt layer is not a local patch. It is a vast, continuous body spread across enormous areas of the basin, buried beneath the seafloor sediments, in places rising into great domes and ridges, where the salt has slowly flowed and deformed under the weight of the rock above it. Salt is strange stuff. Over geological time, it behaves almost like an extremely slow liquid, and it can rise up in columns and pillows through the rock above. So beneath the Mediterranean, out of sight, there is an entire buried landscape made of salt, an enormous geological body left behind by a sea that died. It is one of the largest such deposits anywhere on the planet, and every cubic meter of it was once dissolved in seawater. Every grain of it was carried in through Gibraltar as part of the ordinary salinity of the Atlantic, and then left stranded, crystallized, and abandoned when the water that carried it rose into the sky and blew away. Scientists gave this event a name. They call it the Messinian salinity crisis, after the interval of geological time in which it happened, several million years ago. And once you accept that it happened, you are immediately faced with two enormous questions. First, how? What could possibly cause an entire sea to evaporate? And second, and this is the one that really grips me, what was it actually like down there, in that vast dry hole, when the water was gone? To answer the first, we need to look at a narrow gap of water at the far western end of the Mediterranean, a doorway between the sea and the wider ocean. Because the fate of the entire Mediterranean depends entirely on whether that door is open or closed. Here's the thing about the Mediterranean that most people never think about, and it is the key to this entire story. The Mediterranean is a sea that is losing water all the time. It is, in a sense, permanently dying of thirst, and only one thing keeps it alive. The Mediterranean sits in a hot, sunny part of the world, ringed by warm lands and deserts. Under that sun, water evaporates from its surface at a tremendous rate, rising into the air and drifting away. And what does it get back? It gets rain, but not that much. And it gets rivers, the Nile, the Rhone, the Po, and others. But here's the crucial fact. All the rain that falls on the Mediterranean, plus every drop that every river pours into it, adds up to considerably less than what the sun takes away by evaporation. The books do not balance. The sea loses more water than it receives from the sky and the land. Left to itself, the Mediterranean would shrink. So why doesn't it? Why is it full of water right now? Because of a door. At its western end lies the Strait of Gibraltar, that narrow gap between Spain and Morocco where the Mediterranean connects to the Atlantic Ocean. And through that gap, a constant stream of Atlantic water flows in, replenishing everything the sun steals away. That narrow strait is the lifeline. It's the tap that keeps the bath full while the plug is quietly leaking. It's worth pausing on how astonishingly precarious this arrangement is, because most people have no idea that they live beside a sea held hostage by a single narrow gap. The Strait of Gibraltar is, in the scheme of things, tiny. It is only around 14 kilometers across at its narrowest, a slender thread of water separating two continents. And through that thread flows the entire lifeline of the Mediterranean. Everything that keeps that sea full, every drop that replaces what the sun steals away, has to squeeze through that one gap. Now think about the arithmetic of the situation. The Mediterranean is enormous, with an area of millions of square kilometers, all of it baking under a warm sun, all of it constantly losing water to the sky. The rivers that feed it, even the mighty Nile, are simply not enough to keep pace. The books do not balance, and they never have. It is only that constant inflow of Atlantic water, forced through a gap 14 kilometers wide, that keeps this vast sea alive. Choke that gap, and you condemn the sea. That is not a hypothetical. That is exactly what happened, and it happened because the ground itself moved. Every single day, Atlantic water pours through Gibraltar and keeps the Mediterranean topped up. And it has to, continuously, forever. Because if it ever stopped, the sun would simply carry on evaporating, and there would be nothing coming in to replace what was lost. Now hold that thought and consider that the Earth's crust is not still. The land moves. Africa, on its great slab of crust, has been pushing slowly northward against Europe for a very long time. This is the same collision that has been squeezing up mountain ranges around the Mediterranean, crumpling the land, raising the Alps and other ranges. And at the western end, in that critical zone where Africa and Europe come closest together, that grinding, relentless tectonic pressure was doing something with catastrophic consequences. It was closing the door. Millions of years ago, the connections between the Mediterranean and the Atlantic began to constrict. Tectonic uplifts squeezed and raised the land in the Gateway region. The channels linking the two bodies of water narrowed and became shallower and became restricted. And as that gateway choked down, less and less Atlantic water could get through. The lifeline was being pinched shut. Now think about what that means, given everything we just established. The sun over the Mediterranean does not care about tectonics. It keeps evaporating water at the same relentless rate, day after day, year after year. The rivers keep flowing in, but they were never enough on their own. And now the great replenishing flow from the Atlantic is being throttled. The balance, which was always precarious, tips. More water is leaving than arriving, and the sea begins to fall. At first it would have been imperceptible, a slow decline, the sea shrinking back from its shores, year by year, the coastlines creeping outward, the water getting saltier as the same amount of salt was left behind in an ever-shrinking volume of water. But once the connection to the Atlantic was effectively cut, the process became unstoppable. There was nothing left to replace what the sun was taking. And the sun, over a body of water this size, in a climate this warm, is an extraordinarily powerful engine. It just kept evaporating and evaporating and evaporating. And this is the part that genuinely staggers me. Because the Mediterranean is enormous, you might imagine it would take an eternity to evaporate. But run the numbers, and it turns out that the sun is more than up to the job. If the Atlantic connection were cut today, and evaporation just carried on as it does, estimates suggest the Mediterranean could be substantially dried out in something on the order of 1,000 years or so. In geological terms, that is not slow. That is a blink. That is nothing. On the vast clock of the Earth, this sea could vanish almost instantly. So the Mediterranean was left, cut off, under a blazing sun, and it began to die. The water level dropped and dropped. The sea shrank back, retreating from its ancient shores, leaving behind exposed rock and drying flats. It became saltier and saltier as it concentrated, until it was a brine so extreme that almost nothing could live in it. The salt began to crystallize out and settle on the floor in vast beds. And still the sun kept working, and still the water kept falling, down and down, into the deep basins of the sea floor, until at last the great sea was reduced to almost nothing at all. And what was left behind, once the water was gone, was one of the most extraordinary and hostile landscapes that has ever existed on the face of this planet. Now at last we can go down there. Now we can walk out onto the floor of a sea that isn't there. So let's do it. Let's stand on the ancient shore, on a cliff top somewhere on what is now the coast of Spain, or Italy, or Greece, and look out at where the Mediterranean should be. And there is no sea. There is no blue horizon. Instead, the land simply falls away in front of you into a colossal, hazy, sun-blasted void, an abyss so vast and so deep that you cannot see the bottom of it clearly from up here. Only a shimmering white glare far below, distorted by the rising heat. This is the edge of the world's largest hole. And we are going to climb down into it. The descent is enormous. The floor of the Mediterranean basin is not just a bit below the level of the ocean, it is thousands of meters below. In the deepest parts of the basin, you would be descending 3 kilometers or more beneath the level of the Atlantic on the far side of the Gibraltar barrier. To reach the bottom, you would have to climb down a slope taller than most of the mountains you have ever seen, except you would be going down instead of up, descending into the earth rather than climbing above it. And as you descend, something happens to the air, and it is the first thing that would tell you that this place is truly alien. The air gets thicker, and it gets hotter, much, much hotter, because air pressure increases the lower you go, and the deeper you sink into this basin, the more atmosphere is piled above you, pressing down. Air that is compressed like that warms up. This is a real physical effect, the same reason the air in a deep valley is warmer than the air on a mountaintop, but here it is taken to a monstrous extreme. Descending 3 kilometers below normal sea level into a dry basin would put you at the bottom of an unusually thick column of air, under greater pressure than anywhere on the modern land surface of the Earth, and it would be blisteringly, dangerously hot. Estimates for conditions at the bottom of the dried-out Mediterranean suggest temperatures that could soar to punishing extremes, an environment more like a furnace than a landscape, one of the hottest places the surface of this planet has ever hosted. It would have been, in the most literal sense, a hellish place, a scorching pit sunk into the crust of the earth. And what does it look like down here? It is white, blindingly, painfully white, because the floor of this basin is covered in salt. Vast, endless plains of it, the crystallized corpse of an entire sea, glittering under a merciless sun. Not a thin dusting, but a monumental accumulation, building up over the long agony of the drying, layer upon layer of gypsum and rock salt, in some places kilometers thick by the end of the whole process. Imagine standing in the middle of that, a dead, flat, white desert of salt, stretching away in every direction to a horizon shimmering with heat, with towering rock walls rising far away at the edges of the world, and above you, a blazing sky. It is a landscape that has more in common with our idea of an alien world than with anything you would call Earth. And it is not entirely dry, not everywhere, not all the time. In the lowest points of the basin, there would have been remnants of the sea, but not sea as you know it. Isolated lakes and pools of leftover water, so utterly saturated with salt that they were more like brine than water, dense, heavy, bitter, and lethal. And these hypersaline lakes would be the last sad remnants of the Mediterranean, shrunken puddles at the bottom of the world, so salty that almost nothing could survive in them. The great teeming living sea, with its fish and its corals and its rich ecosystems, was gone. What remained was a scatter of poisonous brine ponds in a scorching salt desert. And what about life? What could possibly survive in a place like this? The answer is very little, but not nothing. Life is astonishingly stubborn, and even in an environment as brutal as this one, there were survivors. In the hypersaline brine pools, there would have been specialized microbes, the salt-loving organisms that can thrive in conditions of extreme salinity that would destroy almost any other cell. These are the same kinds of organisms that today color salt ponds and hypersaline lakes with vivid pinks and reds. So even at the bottom of that furnace, in bitter, poisonous water, there was almost certainly a thin, tenacious film of life clinging on, the last inhabitants of the Mediterranean, holding out in the last drops of a dying sea. And around the edges, at the margins where the rivers came in, there may have been narrow ribbons of fresher water, oases of a sort, where life could persist in the shadow of the Great Salt Desert. But the rich marine world that had lived in the Mediterranean, the fish, the shellfish, the reefs, the whole complex ecosystem of a full sea, was simply gone. it could not survive the transformation of its home into a brine trap and then a salt flat. The Mediterranean, biologically, was wiped clean. And there is one more strange consequence of an empty basin worth mentioning, and it concerns the land. Because when the sea vanished, the Great Barrier separating Europe from Africa vanished with it. Animals that had been kept apart by hundreds of kilometers of open water suddenly had, at least in principle, dry ground between the continents. The salt desert floor was murderous, yes, but the margins and the higher ground and the river corridors offered routes that had not existed before. For a while, the map of the living world in this region was redrawn, with land where there had been sea and the possibility of crossings where there had been none. And now let's talk about the rivers, because this is where the landscape becomes truly spectacular. Remember that the rivers of Africa and Europe kept flowing. The Nile did not know that the sea had vanished. It just kept coming, down through Africa, carrying its water toward the Mediterranean. But instead of gently meeting the sea at a coastline, the Nile now arrived at the edge of an abyss, and it went over. That river had to plunge down thousands of meters to reach the new floor of the basin. And a river falling that far does not do it politely. It carves, furiously. It cuts down into the rock, gouging out a canyon as it chases the floor, deepening its channel, eating backward into the land, tearing a gorge into the continent. Beneath Egypt today, buried and hidden under later sediments, lies the ghost of that canyon, an enormous gorge carved by the ancient Nile, plunging far below the level of today's sea. It is a canyon of tremendous depth, comparable in scale to the great canyons we celebrate on the surface of the earth, and you cannot see a single meter of it because it has been filled in and buried. The same happened in the north, where the Rhone carved a deep gorge down into what is now France, plunging toward that same distant floor. So picture the full scene now in your mind and hold it. A monstrous dry basin, thousands of meters deep, floored with a blinding salt desert, air so hot and so thick at the bottom that it is barely survivable. Bitter, lifeless brine lakes glinting in the lowest hollows. And around the edges, colossal river canyons plunging down the walls, waterfalls of Nile and Rhone water tumbling into the abyss from unimaginable heights, cutting their gorges deeper by the year. This was the Mediterranean, not a sea, a wound, a vast, blazing, salt-crusted scar in the surface of the planet where one of the great seas of the world used to be. And here's a thought that I cannot shake, and I would love to hear what you make of it in the comments. Everything you know about this region, the entire story of the ancient world, Greece and Rome and Carthage and Egypt, all of that maritime civilization, everything that sailed on that sea only exists because the water came back. If it had not, there would be no Mediterranean world at all. There would be a lethal salt desert 3 kilometers deep, dividing Europe from Africa, and the whole history of our species would have unfolded differently. But the water did come back. And the way it came back is, without any exaggeration, one of the most violent and spectacular events in the entire history of our planet. Before we get to the flood, there is something important to understand about that salt, because it tells us the drying was not a single, simple event. It was worse than that. It was a torment repeated. Think about what it takes to make a salt layer a kilometer or more thick. Salt does not simply appear. It comes out of seawater when that water evaporates. But here's the problem. If you took the entire Mediterranean, full of water as it is today, and evaporated every last drop of it, the salt that fell out would form a layer only a few tens of meters thick. That's it. One complete evaporation of a full Mediterranean does not come close to producing what is actually buried down there. To build a salt deposit that reaches a kilometer or more, you would need to evaporate many, many Mediterraneans worth of seawater. So how do you do that? You refill it and you dry it again, and again, and again. The picture that emerges is of a basin that was not simply sealed shut once and left to bake. It was a door that partly opened and partly closed, over and over, as tectonics and sea levels shifted. Water would find its way in from the Atlantic, refilling the basin, at least partially. And then the connection would choke again, and the sun would go back to work, and the sea would evaporate down once more, dumping another load of salt onto the floor. Then another pulse of water, then another drying, cycle after cycle over a long stretch of time, each one adding another layer of salt to the growing pile. The Mediterranean was filled and drained repeatedly, like a bath with a faulty tap and a leaking plug, and every time it dried, it left more of its corpse behind. That is how you build a kilometer of salt. Not with one death, but with many. And this had consequences that went far beyond the basin itself. Because think about what that salt actually is. It is salt taken out of the world ocean. All of it originally came in through Gibraltar as ordinary seawater, and then it got stranded, locked away in the Mediterranean basin, dumped on the floor, and taken out of circulation. And the volume was staggering. A significant fraction of all the salt dissolved in all the oceans of the world ended up sequestered down in that basin. Which means that while the Mediterranean was drying, the rest of the world's oceans were becoming measurably less salty because so much of their salt was being locked away in this one enormous evaporating trap. And that is not a trivial detail because the saltiness of the ocean affects the density of seawater. And the density of seawater drives the great deep currents that circulate around the planet and help regulate the world's climate, exactly the machinery we've explored in other stories. A change in ocean salinity on that scale is a change to a global system. The drying of the Mediterranean was not a local curiosity. It was an event large enough to reach out and touch the chemistry and the circulation of every ocean on Earth. And of course, for the life of the Mediterranean itself, it was an apocalypse. An entire sea's worth of ecosystems, everything that had swum and grown and crawled in those waters, was extinguished as the sea concentrated into lethal brine and then vanished. The rich marine world of the Mediterranean was, effectively, annihilated. When the sea eventually returned, it would have to be recolonized from scratch, restocked by creatures coming in from the Atlantic, a whole sea's ecology rebuilt from the outside. So the basin sat there, this monstrous salt-floored pit, through cycles of partial refilling and brutal drying, for a long, long stretch of time. And then at last, the door opened for good. And what happened next was not gentle, because here is the situation. On one side of the barrier at Gibraltar, you have the Atlantic Ocean at normal ocean level. On the other side, you have a hole in the planet, thousands of meters deep, floored with salt and blistering heat. Between them stands a barrier of rock, and the entire weight of the Atlantic Ocean is leaning against that barrier. Eventually, that barrier failed. Perhaps tectonic movement lowered it. Perhaps the water found a way through, a crack, a channel, and began to trickle over. But once water starts flowing across a barrier like that, something terrible begins. Because flowing water erodes, and every bit of erosion widens and deepens the channel. And a wider, deeper channel lets more water through, which erodes faster, which lets even more water through. It is a runaway process, the same kind of accelerating feedback we have seen tear other systems apart. What may have begun as a modest overflow of Atlantic water into the basin turned catastrophically into something else entirely. Scientists call it the Zanclean Flood, and the evidence buried at Gibraltar suggests it was a cataclysm on a scale almost beyond imagining. The channel was carved out with astonishing speed and violence, gouged deep into the rock, and through that gap, the Atlantic Ocean came pouring into the empty Mediterranean basin. Not as a gentle refilling, as a torrent, as a waterfall and a rapids and a flood of a magnitude the world has probably never seen before or since. Estimates for the peak discharge of this flood run to figures that dwarf any river on the planet today by many orders of magnitude. This one channel at its peak may have been carrying vastly more water than all the rivers of the world combined, thundering down into the basin in a single, sustained, unimaginable deluge. And there is something worth pausing on here about the sheer violence of that inrushing water. Because we are not talking about a sea gently lapping back into place. Think about the drop. The Atlantic sits at normal ocean level. The floor of the Mediterranean basin lay kilometers below that. So the water was not flowing in horizontally, it was falling. Pouring off the edge of one world into the depths of another, down a colossal incline, accelerating as it went, tearing at the rock beneath it, and ripping out a channel as it came. The erosive power of water moving like that is almost impossible to overstate. It would have excavated the gateway at Gibraltar, deepening and widening it at a frightening rate, and each time it did so, it let even more water through. And the sound of it. We can only imagine, but a torrent of that magnitude, thundering down into an empty basin for months or years without pause, would have generated a roar unlike anything that has been heard on this planet in the whole span of human existence. A permanent, planet-scale thunder, echoing across a salt desert, as an entire ocean poured itself into a hole in the world, and the basin filled, fast. Because of the sheer rate of that inflow, the modeling suggests something extraordinary. The Mediterranean, this enormous sea, may have been refilled not over thousands of years, but potentially in a matter of a couple of years, or even months in the most rapid phases. Water levels in the basin could have been rising by many meters a day. Imagine standing on that salt desert floor, in that furnace of an abyss, and seeing on the western horizon a wall of white water advancing across the plain toward you, a flood rushing in from a gap thousands of kilometers away, filling the hole where a sea should be, climbing the walls, rising by meters every single day, drowning the canyons, drowning the brine lakes, drowning the salt, until the entire basin was full of water once more, and the Mediterranean Sea existed again. And that, in the end, is the sea that we know. The sea that ancient civilizations built their world around. The sea where people take their summer holidays. It is a sea that was killed and then resurrected in one of the most violent floods this planet has ever produced. The salt, the corpse of the old sea, was buried beneath the new one, hidden under layer after layer of sediment, where it lies today, kilometers thick, waiting for a drill to find it and tell the story. And here is the part that stays with me. Everything about that region seems permanent. The Mediterranean seems like a fixed, eternal feature of the map, as solid and unchanging as the continents around it. And it is not. It vanished. It came back. It vanished again, repeatedly. And the only reason it is there today, full of water, is that a narrow gap of water at Gibraltar happens, at this moment in geological time, to be open. That is all. One slender strait, a doorway a few kilometers wide, is the only thing standing between the Mediterranean Sea and its return to a scorching, salt-crusted abyss. If tectonics close that door again, and given that Africa is still pushing northward, it may well close eventually, the sun would go straight back to work, and the sea would begin, once again, to die. That is the real lesson of the Messinian salinity crisis. Not just that a sea can vanish, though it can, but that the features of our world that look most permanent to us, the ones that feel like they were always there and always will be, are in truth only temporary arrangements, held in place by conditions that can change. A sea is not a permanent fixture. It is a balance between the water coming in and the water going out. And balances can tip. So the next time you see a picture of the Mediterranean, that beautiful blue sea with its ancient coastlines and its islands and its ships, look at it a little differently. Beneath all that water, buried under the sea floor, lies a kilometer or more of salt, the remains of an ocean that died. Beneath Egypt, buried and invisible, lies a canyon carved by a river falling into a hole. And out at Gibraltar, a narrow strait keeps the whole thing alive. The Mediterranean is not a permanent sea. It is a sea that has been switched off and switched back on, and it is only full today because a door happens to be open. If this journey to the bottom of a vanished sea stayed with you, tell me in the comments which part you found hardest to believe, and subscribe, because the story of our planet is full of these impossible places, and we are going to keep descending into them, one by one. Because the ground you stand on and the water you swim in are only ever borrowing their permanence from time. Nothing on this planet is as fixed as it looks, and the Mediterranean is the proof, hiding in plain sight beneath the waves.